So very good morning, all of you. So I think in the last class I explained about the microwaves. It is in the class one. And the continuation of that one is the class two. It is to be concerned with the waveguides here. Okay, and it is to be concerned with the subject for the advanced communication for the fifth semester diploma. Okay, and in this class, I am going to explain about the definition of the waveguide and the advantages of the waveguides and the types of the waveguide, and we'll also see the differences between the actual transmission lines and the waveguides. Okay, all these topics it is going to be covered in this class here. Okay, if you take the definition of the waveguide, so that it's nothing but only the metallic tube here. Okay, so if you take the metallic tube, means if you take any of the pipe, it is to be manufactured with the metal, it is itself is acting as of the waveguides here. Okay, so that if you take any of the metallic tube and it is to be of the it is its cross section is going to be the what uniform. So means it is going to be the same. It is from the one end to the other end, and it is mainly used for transmitting the what electromagnetic waves. It is by the successive reflections from the inner walls of the tube itself is called as the waveguide. Okay, so that if you take any of the pipe, it is implemented with the metal. Okay, either it may be in the rectangular shape or it can be in the circular shape. Okay, so that you can able to see in the diagram here. Okay, if you take any of the empty tube, okay, implemented with the metal, and its internal space is going to be same across the entire length of the tube. Okay, itself is called as the waveguide here. And if any of the signal is to be transmitted into the waveguide, means it is to be transmitted as of the what electromagnetic waves. And in this case what happens, each of the successive waves is to be get reflected with the inner walls of the tube here, and it is to be transmitted from the one end to the other end. Okay, already you know about the microwaves. So if you take the microwaves, so it is to be get reflected with the metals, and it is going to be refracted, it is with the non-metals here. Okay, so it has been studied in the previous class there. So that if any of the tube, if it is to be implemented with the metal, and if the microwave signal is to be passed into the tube, means in the it is to be get it is to be get reflected with the inner walls of the tube, and it is to be transmitted from the one end of the tube to the other end of the tube, and itself is called as of the waveguides here. So a waveguide is any the metallic tube of the uniform is cross section. It is used for transmitting the electromagnetic waves. It is by the successive reflections is from the inner walls of the tube is called as the waveguide. It is it is the technical definition of the waveguide here. Okay, and if you take the characteristics of the waveguide, so that the waveguide is a special form of the transmission line. So it is also acting as of the transmission line only. So that in this case, the microwave signals is to be get transmitted from the one end of the tube to the other end of the tube, and it is by reflecting inside with the inner walls of the tube. So it is going to be transmitted by the reflections, means it is also acting as of the transmission, okay, line here. And the implementation of the metal tube is going to be the halo. So it is to be the what halo means, the metal tube, it is going to be the empty tube there. And a waveguide has no center conductor. So that if you take any of the transmission lines, either of the coaxial cable, or if you take the twisted pair cable, or any of the cable, or any of the transmission line other than the waveguide, it is to be implemented with the center conductor. So but if you take the waveguide, it is going to be the empty. It is going to be the what? Empty means it is center conductor is not available in the waveguide here. And the entire length of the tube is to be implemented with it is to be implemented with the distributed inductance, so that inductance it is going to be distributed along the entire length of the tube there. And the empty space between the tube walls is going to provide the distributed capacitance, so that if you take the upper wall, and if you take the lower wall, and if you take the space between the upper wall and the lower wall, is acting as of the dielectric, and it is going to acting as of the capacitor also. So for that purpose, the empty space between the two walls is going to provide the it is going to provide the distributed capacitance along the entire length of the tube there. And it is going to be the bulky and expensive. All these are the important characteristics of the waveguide. So I am going to repeat once again. So the waveguide is a special form of the transmission line, and it is going to be the empty metal tube. And the waveguide is not having the center conductor, and it is the inductance is to be distributed along the length of the tube. The entire length is to be assumed as of the inductor. And the empty space between the inner wall of the tube is acting as the capacitance, and it is also distributed along the length of the tube. And it is going to be the bulky and expensive. It is going to be the bulky means it is having the more weight, and it is expensive means it is of the high cost here. All these are the important characteristics of the waveguide. Okay, and if you take the need of the waveguides, it is why do you need of the waveguides here? And it is itself is nothing but an advantages of the waveguides. So if you take the advantages of the waveguides, it is very easy to manufacture. I think you know about, if you want to implement any of the empty pipe, it can be implemented very easily there. So it is very easy to manufacture, and it can able to handle the very large power, especially in terms of the kilowatts here. It is one of the important applications of the waveguide also. Okay, so it can able to handle the very large power here. And in case of the waveguides, if you take the power loss, it is going to be the negligible, or it is going to be the very very less here. So that if you take any of the coaxial cable, or if you take the twisted pair cable, so it is some of the power it is going to be lost in the form of the heat there. But in this case, if it is to be compared to that transmission lines, so it is going to be the very less here power loss. So it is going to of the very low power loss because of the alpha attenuation factor. The attenuation factor is very less. Attenuation factor means it's what about the cutoff? It is going to be the very less. Obviously, according to the attenuation is very less means according to that its upper loss is also very less here, and its energy experiences of the lower loss if it is to be compared with the coaxial cable. It is itself, I said, it is while explaining the third point here. If it is compared to other transmission lines, in this case, the loss is very less here. Okay, I am going to repeat once again the advantages of the waveguides. The important advantages of the waveguides are: it is very easy to manufacture, and it can able to handle the very large power. It is in terms of the kilowatts. And in this case, if you take the power loss, it is going to be the very negligible, and it is going to offer the very loss. It is especially because of the low value of the alpha here. I think you know about the alpha, beta, and all that. It's nothing but the attenuation factor, output by input. It is going to be the very low value here. So according to that one, so that offer loss is also very less here. And if it is to be compared with the other transmission lines, its losses experiences is going to be the very very less here. So all these are the advantages of the waveguides here. Okay, and after that, if you take the types of the waveguides, it is to be classified into the many, it is to be classified into of the main five types here. It is to be classified according to its shape. Okay, it is to be classified as of the rectangular waveguide. It's to be classified as of the circular, elliptical, the single ridged line. One more is the double ridged here. Okay, if you take the rectangular waveguides, so means it is of the rectangular in shape. I think you know about the rectangular. It is to be distributed along with the length and the breadth here. Okay, so this, so what this horizontal part is, it is assumed to be as of the length, and if you take as of the vertical part, it is assumed to be the breadth, and so the entire length is to be represented as in that way only, so that the opposite sides of the walls is of the same length here. Okay, so if it is having the shape of the rectangular, it is called as of the rectangular waveguide. And if it is of the circular, exactly the cylinder here, so it's a 3D diagram, so that you can see here. So it's 3D diagram. It is assumed to be the circular waveguide here. Okay, this circular path is to be indicated along the entire length of the tube here. Okay, so if its a shape is going to be the circular here, it is called as of the circular waveguide. And if its shape is assumed to be of the elliptical, I think you know of the elliptical. It is to be represented with the major axis and the minor axis. If you take the major axis, it is of the more length, and if it is to be compared with the minor axis, it is of the less length here. Okay, so that it can clearly shown in the diagram here. So if the shape is of the what elliptical in shape, it is called as of the elliptical waveguide. And another one is of the single, okay, rigid. So it is having the bends at the one end here. It is same as of the rectangular, or it is assumed to be the extension of the rectangular waveguide here. So if it is having the bends, so that you can able to see the bends at the one end. If it is having the bends at the one end, it is called as of the single ridge. And in the same way, if it is having the bends at the double ends, so that you can able to see the upper end is to be bended there, and also the lower end is also to be the bended, and it is going to take the shape of the H, the English alphabet H. If it is going to take the English alphabet H, it is assumed to be the double rigid waveguide. Okay, so that if you take the types of the waveguide, okay, it is to be classified into of the four types here. One is the rectangular waveguide, another one is the circular waveguide, another one is the elliptical waveguide, one more is the single rigid, one more is the double rigid. So all these classifications is to be based entirely on the shape of that waveguide. Okay, if it is of the rectangular in shape, is called as of the rectangular waveguide. If it is circular in shape, is called as of the circular waveguide. If it is elliptical in shape, is called as of the elliptical waveguide. And if it is having the bendings at the one end, is called as of the single rigid waveguide. And if it is having the bending at the two ends, is called as of the double rigid waveguide. Okay, it is about the classification of the waveguide here. Okay, and if you see the differences between the ordinary transmission lines and the waveguide. So the ordinary transmission lines means what? If you take the coaxial cable, or if you take the single ended wire, or if you take as of the multi stand wire, if you take the single stand wire, if you take as of the twisted pair cable, so all these are acting as of the transmission lines. It is having the inside core in it. And if it is to be compared with the waveguides, it's what's the differences, we'll see that now. So if you take the transmission lines, it is going to support the TEM wave. It is a transversive electromagnetic, so that it can able to be operated with either the electric or of the magnetic, only one. But if you take as of the waveguide, it cannot support the TEM. It is to be combined with the TEM here. Okay, and after that, if you take the another differences, all the frequencies it can able to pass in the ordinary transmission lines here. Okay, all the frequencies it can able to pass very easily in the ordinary transmission lines. If you take as of the waveguide, it is having the cutoff frequency here. Okay, so only the higher frequencies it can able to pass into the waveguides. I think you know the frequency band of the microwave signal. It is from it is from it is from the 300 megahertz to it is 300 gigahertz here. So it is of the large frequencies, so that it can able to pass only the large frequency signals here. And in the transmission science, it is to be implemented with the one conductor, but in the waveguides it is to be implemented with the two conductor transmission. It is having the positive cycle as well as of the as well as the negative cycle. It is to be heated with the inner walls of the tube there. And if you take the reflections, it is going to be the very less, but in the waveguides it is going to travel with the reflections only. So the wave travels, it is with the reflections from the inner walls of the waveguide here. Okay. And if you take the characteristic impedance, it's available in the transmissions lines, and it is to be represented with the wave impedance here. And if you take the propagation of the waves, it is based on the circuit theory here. So if you take the movement of the signal in the transmission is to be based on the circuit theory. So an example is its flow of the current in the circuit diagram. Okay, it is to be concerned with the transmission lines, but in this case the propagation is to be according to the field theory. So in this case, what happens? The available waveguide tube, it is going to be the empty tube. It's not so that it's not having the inner core conductor. So it is to be based on the field theory here, on an empty space here. And it should have the return conductor of the earth, so where it is in the transmission lines. But in case of the waveguide, it's what the return conductor is not required. The existing body itself is of the metal there, so it is itself is going to act as of the earthing there. Okay. But in this case you should form the closed loop here, so that one end is to be certainly connected to the ground in order to form the closed loop here, but in this case it's not required here. And if you take the bandwidth, it is not limited in case of the transmission lines. Obviously it is going to pass all the frequencies, means it's not having the bandwidth at all. But in this case it is to be based on the cutoff frequency, means its bandwidth is going to be limited here. So in explaining the spectrum band, I explained it's what's the bandwidth there. So each of the band or each of the range is to be represented with one alphabets there. Okay, according to that bandwidth only it can able to transmit the signal here. This is about the waveguides. And after that, if you take the waves, it is not going to disperse. Obviously it's the flow is available only in the transmission line. But in the waveguides it can be dispersed. Either it can enter into the waveguide, and if it can also come outside from the waveguide if it has been open end. Okay, this is itself is the differences between the transmission lines and the waveguides. Again, I am going to repeat it as in brief. So, in the transmission lines, it is going to support the TM. In the waveguides, it's not support the TEM. In the transmission line, all the frequency is going to be passed, but in the waveguide, only the frequencies of the cutoff is going to pass. And in the transmission line, it is able to conduct with the one conductor transmission, but in this case it is to be conducted with the two conductor transmission. And in this case the reflections are less or negligible, but in this case it is going to travel, or it is with the reflection only. It is from the inner walls of the waveguide here, and it has the characteristic impedance. It has the wave impedance. And in this case the actual propagation of the wave is according to the circuit theory, but in this case the propagation of the wave is according to the field theory. And it should have the return conductor, it is to the earth in the transmission in order to form the closed loop. But in this case return conductor is not required, so as the body of the waveguide itself is acting as the earth there. And if you take the bandwidth, it's not limited, it is going to pass all the frequency signals, means its bandwidth yeah, so it's not limited in the transmission line. So but in the waveguide its bandwidth is going to be limited here. but and in the transmission slice, the waves is not going to disperse. If it has been indicated with the open end also, it is not going to transfer. But in the waveguides, if the waveguide is to be open, so it is going to disperse into the air here. So this is itself is the differences between the transmission lines and the waveguide here. Okay, so in this class, the actual definition of the waveguide has been studied, and what are the characteristics of the waveguide has been studied, and the advantages of the waveguides has been studied, and also how many types of the waveguides along with the shape has been studied, and what the differences between the ordinary transmission lines and the waveguides is also studied. Okay, so if you are having the any doubt means you can ask, and in the next class we'll see about the energy coupling. So if you are having the two waveguides, if it has to be get coupled, it is what is the procedure to be get what is the procedure to be get coupled, and and what is the procedure to get input the energy into the waveguide, and what is the procedure it is to take the energy from the waveguide. So all this uh, we can see in the next class under the energy coupling concept. Okay, thank you. Okay, thank you very much.